Hello, ladies and gentlemen. I'm here from you again, and today I'm going to present you a short version or lightweight version of my talk. Today I will consider just the single pattern. My idea is that I will be giving you short talks instead of full-sized one, just to make our communication probably more flexible and probably more convenient to you. So again, today we will consider just one pattern, and I will continue uploading my talks more often, not just once a week. Again, in order to make it probably more convenient for you. So again, today we will take just a moment. Today we will consider, excuse me for these common slides. I put these slides in front of my each talk just to make you a kind of reminder about the context of our considerations. So look, today we will consider so-called flyweight pattern. This is a very simple one. For those of you who understand Russian, the typical Russian translation of this flyweight word is приспособление. I'm not sure this is a kind of good translation, but well, it is taken in many books. But it doesn't matter. Now I am going to concentrate on the semantics or meaning of this pattern. This is a very simple one. And by the way, this is the last structural pattern we are going to consider within the course. Next time, we will start considering some important behavioral patterns, поведенческие patterns. So, look at the slide. Which problem do we have while designing our software, and which one is to be solved by this pattern? The problem is how to struggle with a big number of small objects. It is very typical problem. I will give you some examples later. Well, flyweight pattern just gives us the solution for that. Erich Gamma gives us a formal definition of this pattern. He writes, use sharing to support large numbers of fine-grained objects efficiently. By my opinion, this is a very unclear explanation. This is just a formal answer for formal description of the pattern. To be honest, I'm not happy about it. Oh, sorry, excuse me, let's go back. Again, this is not a very clear explanation. I would prefer to give you a more clear explanation using some examples. So look at the next slide. Consider a software that simulates traffic. This is a very typical kind of software that we can see this or similar kinds of software around. There are many simulating programs modeling some real-world aspects. Anyway, let's take this task. Traffic is a kind of how cars, how vehicles are moving around the streets, and what's the main contents of such a task. Look, there are a lot of objects in this software representing cars. there are a lot of cars. We need to check how or control how they move around the streets. Each car has a limited set of attributes. Typically, for traffic simulation, we need just car coordinations, car size, and car speed. That's basically it. And the behavior of each entity, of each object, of each car object is quite simple. We just need to know the only kind of behavior. This is just how this vehicle is moving. Okay, let's quickly consider another example, text editor. This is a little bit more complicated software, but typically each text editor deals with different kind of objects. Look at the possible structure of the text being controlled by a text editor. First of all, we have any text typically contains a sequence of pages. This is the big elements of each text. Each page consists of text lines. We are now considering just text editor. And each line consists obviously of characters. If we are developing a kind of full-fledged text editor, we need to be able to control characters, control attributes of each character. The attributes are size, font, color, and probably some others. But again, the same situation. We have a lot of, in general, we have a lot of small objects representing characters. Of course, we also have lines, pages. There are also can be quite a big number of such entities. Again, entities. There is a big number of entities representing text components, and the behavior of each entity is quite simple, if not trivial. Actually, the only kind of behavior of each character or line or page is to display itself on the screen. Okay, so the same situation. A lot of objects with a limited set of attributes and very simple or trivial behavior. Let's consider the third example, landscape design. This is also a kind of popular kind of software. There are a lot of different landscape-oriented, architectural-oriented design software. Again, very similar situation. A lot of objects representing, in this case, garden plantings, trees, bushes, etc. Each planting has a limited set of attributes. In the case of landscape design software, it is a kind of a planting, bush or tree, or probably something else. Its size and its age. Probably the age attribute is also necessary for modeling landscape. And again, each entity has very trivial behavior. For the case of landscape design software, this behavior is just to display a particular planting on the screen. Okay, so we have 3 examples. I can give you more ones, but well, it's quite enough for us for today. So, there are major common features of all those and other examples. Great number of objects with limited number of attributes and simple and unified behavior. Okay, so how do we typically solve or implement software like shown on examples? Actually, there are 2 possible ways. The first solution is just to directly implement what is specified in the task. That is, to create a particular instance for each object of the system. But a separate object entity for a character in a text editor, each create instance for each planting or for each car in traffic control or traffic simulation software. Of course, it consumes a lot of memory. There are a lot of small instances in memory, and in order to control all of them, it takes a lot of time, both memory and processor time. So it slows down the efficiency. And as you might guess, another solution is to apply flyweight pattern, to have the single object. What does flyweight give us? It gives the possibility to create the single object representing all system entities, keeping all object states in a separate object. Conceptually, this is a very obvious approach, but well, formally this is defined as a specific pattern. By the way, I would admit that even before reading a book about design patterns, I often used the same approach in my programming, programming things. But when one day I read the book and I understood that I was using this pattern without any knowledge about the classification, pattern classification. Okay, let's consider a schematic example. So it is too simple, the pattern is too simple to talk about it very long. So let's consider probably the simplest example, landscape design. I have drawn a schematic picture illustrating the idea. Suppose we have an area with a house on it, and our idea is to put trees within this this area. Okay, so what is the first approach, direct solution of the thing? For each planting within this area, we create a class. Well, I've called it tree. The class has obvious attributes, coordinates the age of a tree. What do we have in this class defined, except attributes? Just a constructor. I don't care about parameters and the body, it seems to be obvious. And probably the single function specifying the behavior of the planting, of the tree. Just display it on the screen. Okay, and what's the conclusion? How this the program containing this class declaration will run? Obviously, we will have a lot of entities, instances created by this class. Each instance keeps its own state. Again, this is a kind of direct and good. In many cases, this solution is quite good, just because it is simple. It is direct, simple, and obvious. And it just works if we don't have a big number of instances. My picture illustrates just, well, dozen of instances. This is not a problem. But imagine the situation, for example, with traffic simulation system. There are a lot of cars and unpredicted number of cars. If we have a full-sized simulation system, such a big number of cars will slow down the efficiency significantly. Okay, so how to organize our solution in other way. Look, instead of having a tree instance for each tree, I have specified a class called tree array. The idea behind this class is that it should keep the information or attributes of all trees in the area. I have written array of coordinates and ages. I don't care about the details of how this array is organized. It is quite enough for me to know that there is a container that contains all information, all attributes for all trees within our program. And look at the member function, display. Again, I don't care about precise implementation of this. It is quite enough for me to specify the idea of this display function. It will take necessary attributes to X, Y, and age that characterize a particular tree and applies display function for a separate class called tree. Look. So, for each tree, I have defined the single class called tree with the single function display. It accepts X, Y coordinates and age and just displays the tree with corresponding arguments. And tree array function just calls this function with the given arguments. So what is the result on the runtime? Look, instead of having a big number of instances with their own attributes, we have just two instances, the instance of tree array and the instance of tree. Tree array contains attributes for all instances, and the tree instance provides the unified behavior for all kinds of trees. That's it. That's it. Very, very simple and very obvious and very easy to implement better. So I recommend you to think about using this pattern every time when you deal with great number of small or lightweight objects. That's basically it. Again, this talk is quite short, quite simple. I will give you the continuation of this of our talk within this week. And the final slide is some conclusions. Advantages and use, when to use flight weight, and disadvantages, of course. Each approach has both advantages and disadvantages. So, as you might already understand, flight weight pattern dramatically reduces the number of object instances. Therefore, it reduces memory consumption, and in many cases, it increases the efficiency of the whole software. And of course, separate storage for the state of all instances is also an advantage. The conclusion is the next point is again quite obvious. There are many class instances with the same behavior. Then think about using flight weight pattern. Of course, some disadvantages. Probably the most disadvantage is, well, the obvious disadvantage is that the pattern, it is reasonable to use this pattern for a specific configuration, a great number of lightweight objects. One more disadvantage is that after implementing, it is not possible to improve behavior of a particular instance. All the examples before were about the unified behavior. Each car can just move or just stop. That's it. Each plant has trivial behavior just show itself on the screen. The same is about characters in a text editor. The only behavior is just change the state and probably display itself on the screen. If you need to improve such a behavior and to make such a behavior different for different instances, you fail, or it is not recommended to use flyweight pattern. So that's basically it. This short talk will be uploaded to Moodle probably, or to YouTube. I don't know whether Serozhedin decides to do with this talk. And I'm open to get your questions and remarks probably, again via Moodle. So thank you for your attention. See my further talks quite shortly. Thank you.